Hello everyone, welcome back to Spectrum classes. In this video, I am going to discuss about the electrochemical cells. There are two different type of electrochemical cells. One is electrolytic cell and the other one is galvanic cell. These galvanic cells are also known as voltaic cells. So here in this video, I am going to discuss about the basic terminology which is used in electrochemistry, and this will be very helpful for the beginners. The second thing which we are going to discuss here is the basic working principle of galvanic cells as well as electrolytic cells, and here for galvanic cell I am using the example of Daniell cell. In addition to that, we are also going to discuss about the electrode potential as well as EMF, which is also termed as electromotive force of the cell. So we are going to discuss these two terms, and we are also going to see the similarities and differences between the electrolytic cell and galvanic cell, which is very useful to understand the similarities and differences between the electrolytic cell as well as galvanic cell. So let's start with the video. So what is called electrochemical cell? An electrochemical cell is a device for the conversion of electrical energy into chemical energy or vice versa. Right. So here we are having two different type of electrochemical cells. One is electrolytic cell and the other one is galvanic cell. And these galvanic cells, as I told you earlier, are also known as voltaic cells. So here you can understand the difference between two. Here electrolytic is further divided into electro plus lysis, right? This Ly stands for lysis. So electro stands for electricity and lysis stands for breakdown. So by using the electricity, we are going to break down the non-spontaneous chemical reaction. And here I am going to give you the example. Say I am having sodium chloride which is in molten state. You can understand we are having the salt which we are using, sodium chloride, and that is in molten form. So that is breakdown in the form of sodium plus chlorine gas, right? So in this form, if it is fragment, so that is only possible by electrolytic cells. Now coming to the galvanic cell. In the galvanic cell, free energy, this free energy is represented by delta G. And if you are a student of up to class 10, so you don't understand this. So you simply understand that energy of a chemical reaction is converted into electrical energy, right? So I'm here giving you the example. Say I am having copper in solid form, silver in aqueous form, and if I put these two together, then I will get copper 2 plus 2 silver, and in this case electrons are generated, right? Now we are first going to discuss the working of electrolytic cell, how it works, right? So here is the diagram of electrolytic cell, and in this electrolytic cell we are having two metal rods. So here one is known as anode and the other one is known as cathode, these two metal rods, right? And these two are placed in the same compartment. We are saying anode to this metal rod which is connected to the positive terminal of the battery, and here cathode is known as the negative terminal because it is connected to the negative terminal of the battery. But what is called anode actually? So anode is the metal rod onto which oxidation occurs, and cathode the metal rod onto which reduction occurs. But here these two plus and minus are termed as their terminals. These are not anode and cathode. So in case of electrolytic cell, anode is positive terminal and cathode is negative terminal because these two are connected with the positive and negative terminal of the battery respectively, right? So this is how you can understand the anode and cathode here. Now coming to the next, here you can see this sodium and chloride which is in the form of their ions. Ions means they are having positive or negative charges, and these Na plus and Cl minus is known as electrolyte, and here in this case molten NaCl is the electrolyte, right? So what is called electrolyte? Electrolytes are those substances that can conduct electricity through them by movement of their ions to the electrodes, in solution or in molten state. Positively charged ions are known as cations, whereas negatively charged ions are known as anions. Cations migrate towards the cathode and anions migrate towards the anode. So here, if you forget about that, so you can relate these cation and cathode, anion and anode. So both started with the same letter. So here, this anion migrates towards the anode and this cathode migrates towards the cathode. So here you can see in this manner, and while they are passing through this, and the reaction which is occur on the anode is written over here. Here we are having Cl minus ions. So these Cl minus ions releases electrons and they form chlorine gas. And on the cathode I have already written that reduction occurs. So here sodium plus ions which is present over here, sodium plus ions, on accepting the electrons they produces sodium metal. So this is in the molten state. In aqueous state we do not get the sodium. So here on the anode oxidation occurs, on the cathode reduction occurs. This concept of oxidation state I will give you in the upcoming videos, right? So here it is better to understand, here it is losing the electron. So loss of electron is termed as oxidation, and gain of electron, because it is accepting the electrons, so gain of electron is termed as reduction. So I hope you understand these 2 points. The overall reaction we can write down after combining these two equations. So this is the working of electrolytic cell. Now we are coming to the galvanic or voltaic cells. So I am taking the example of Daniell cell, and as I mentioned earlier that in this kind of cell, free energy of the chemical reaction is converted into electrical energy, and I have given the example of zinc and copper. So here zinc on reaction with copper 2 plus, it will produce this zinc 2 plus copper metal. Now I am going to give you the arrangement of Daniell cell. So here we are having two different beakers or containers, and in one beaker we are having the zinc rod. This is the zinc rod. This is dipped in the zinc sulfate solution, and here it is the copper rod, and this is dipped in the copper sulfate solution, and these electrodes are connected to the ammeter which will record the current passed through this cell. These zinc sulfate and copper sulfate are known as electrolytes, zinc 2 plus sulfate 2 minus. Similarly, copper sulfate breaks down into copper 2 plus and sulfate 2 minus ions. So here I have shown these ions with these circles, right? Different color schemes. So here zinc represents this gray and sulfate represents this pink color. Similarly, this copper sulfate, copper represented by this blue and sulfate represented by this pink color. So here this zinc rod behaves as anode and this copper rod behaves as cathode. Here in this case, this anode behaves as negative terminal, whereas this cathode behaves as positive terminal. So in what I have discussed in the previous slide, in case of electrolytic cell, that anode is positive terminal and cathode is negative terminal. But here in case of galvanic cell, these two terminals are opposite. And please be cautious about this terminology because students get confused over here. In the next slide, I am going to tell you why it is so. So you will never forget about this, right? Now, the external circuit is complete, but what about the internal circuit? The internal circuit will be completed by adding this U-shaped glass tube. What is this U-shaped glass tube? This is known as salt bridge. And this salt bridge, this U-shaped glass tube is filled with the aqueous solution of electrolytes. So here we are using the KCl electrolyte. In addition to KCl, we can use KNO3. And if you are student of higher classes, then you can understand the transport number. So in this U tube or salt bridge, we are using only those electrolytes which are having transport numbers for both cation and anion same, right? And this salt bridge helps us to complete the circuit. First, it prevents the mixing of these two electrolytes. Second, and it also maintains the electrical neutrality during the reaction, right? So that I will tell you later on. So here is the KCl which we have filled. So I am just going to show you the color schemes. And on the anode, oxidation reaction occurs as I told you earlier. So loss of electrons. So zinc converted into zinc 2 plus by losing 2 electrons. This is the oxidation reaction, loss of electrons. And here on the cathode we are having the reaction copper 2 plus plus 2 electrons, and this gives you copper metal or copper atoms, from ion to atoms, right? This is on accepting 2 electron or gaining 2 electrons. So gain of electron is known as reduction. This is the reduction reaction, and now we are going to understand how this Daniell cell works. For understanding the mechanism or working of this Daniell cell, we are going to consider the Nernst theory, which was put forth in 1889. He is the very famous scientist, and he also gives his equation which is known as Nernst equation. And on the Nernst equation I have already made one video, right? So he proposed that there are two different pressure mechanisms. One is electrolytic solution pressure of metal, and the other one is osmotic pressure of metal ions. So what these two pressures are? Because of this electrolytic solution pressure of the metal atoms move into the solution in the form of ions, and they leaving the electrons on the metal surface. And then second one is osmotic pressure of the metal. Because of this osmotic pressure of the metal ions which are present in the solution, they takes up the electrons from the metal rod and they convert it into the metal atoms, and they leaving the positive charge over the metal surface. So first I will show you these two statements by the example. If this is going to be happen, then this type of reaction will occur. So zinc, on losing the electrons, they will produce zinc 2 plus ions, and it goes into the solution. And because of the osmotic pressure of the metal ions which are present in the electrolytic solution, they take up electrons from the metal rod and they convert it into atoms, right? And out of these, whichever pressure is the dominating pressure, that kind of reaction occurs over the with that metal rod and the electrolyte solution. So first understand this mechanism, right? So you just see over here, I'm going to show you, because in this case this is the dominating one, and since this rod is made up of atoms, so it leaves in the form of zinc 2 plus ions and leaves the electrons over here. Similarly, I have shown some more atoms are going into the solution, leaving the electrons over there. And because of these electrons, this anode becomes the negatively charged terminal. And here, if you have seen, you just see again. So here, this copper from the solution, this goes up to this metal rod, and it takes up the electron from the metal rod, and it deposited in the form of this copper atom, leaving the positive charge over there, because it extracts two electrons from this metal rod, because this osmotic pressure of the metal ions is dominating in this case, right? Similarly, I am again showing you that some more atoms coming to this metal rod take up the electrons from this metal rod, leaving the positive charge over there. So here what happens, this becomes the negative terminal and this becomes the positive terminal because of the production of these electrons and positive charges over these metal rods. Getting my point? So this is the whole concept behind their generation of terminals or terminology of the terminals. So this is anode, to which electrons are come up. Now what is going to be happen? Since positive charge developed over here, so this will attract the electrons from this zinc metal rod. So here these electrons are moving in the outer circuit, and in that case this ammeter recorded how much electricity is produced, right? And On accepting these electrons, this metal again becomes neutralized, right? The next thing which we are going to consider here, in this process here the number of zinc ions increases, whereas in this compartment number of copper 2 plus ions decreases and the sulfate ions remains the same. So just here negative charge dominates, as you can see more number of sulfate ions, and here you can see more number of zinc ions, right? So while this occurs, so here these sulfate ions are moving through this salt bridge. So here you can see, and they will pair the zinc ions, right, to maintain the electrical neutrality. But as the time passes, the formation of this zinc 2 plus ions in this compartment increases and deposition of these copper ions on the metal rod increases. And the movement of these sulfate ions is not occur at that rate, right? So what happens in that case? The positive charge on this cathode occurs and the negative charge develops over this anode, and to maintain that electrical neutrality the zinc ions which are produced over there, they will come into the vicinity of this metal rod just to neutralize that, or just to have into the vicinity of this. Similarly, these sulfate ions are gathered over there or come into the vicinity of this cathode, and they will now not allow to attract the electron by the cathode as well as by the movement of electrons through this anode. So at this moment a stage of equilibrium occurs and no further movement of electrons takes place in this cell. So at this moment what is going to be happen, this salt bridge come into the and it rescue this position. So it releases potassium ions which are positively charged, here shown by this green color. They come into the they move towards the compartment of these copper ions where sulfate ions are in high concentration, and the Cl negatively charged ions which are represented by these red circles, they move into the left compartment or in the section where zinc ions are high in concentration to maintain the electrical neutrality so that the reaction further proceeds. So this is how this anode becomes the negative terminal and this cathode becomes the positive terminal in case of galvanic cell, right? So here you can see this. So this is known as development of electrical double layer. Double layer means negative charge and positive charges come together, and this is known as electrical double layer. And the formation of this electrical double layer is known as electrode potential here on this anode as well as on cathode, which facilitates the movement of electron. So here this is the electrode potential for this anode and this is the electrode potential of this cathode. So we can measure the electrode potential of the half cell. Now we are going to understand what is called electrode potential. So the tendency of an electrode to lose or gain electrons when it is in contact with its own ions in solution is called electrode potential. So this is known as electrode potential. For the half cell reaction, we are having this type of reaction at this electrode, right? So zinc converted into zinc 2 plus 2 electrons. The potential of this electrode is termed as half cell electrode potential, and which is determined by the Nernst equation. And the Nernst equation, as we know, E stands for electrode potential. E is equal to E naught minus 0.0591 upon N log base 10 K. So what is the K? K is the, since this reaction is in equilibrium, so zinc 2 plus upon zinc, right? Electrons doesn't take part in case of this, right? So here N stands for 2 electrons, right? So what is this E and E naught? E is the electrode potential in the actual conditions and E naught is the standard electrode potential. So what is this standard electrode potential? Now we are coming to understand the standard electrode potential, which is determined through this ammeter, and here you can see the reading. So this is the copper solution and this is the zinc solution. Now coming to the standard electrode potential. So electrode potential of a cell is known as standard electrode potential, or it is represented by E node when the pressure is 1 atmosphere, temperature is 298 K, and the concentration of the electrolyte solution is 1 molar. Now coming to the electromotive force. So electromotive force is the E cell is the potential difference between the two half cell. So E cell, this completely form the cell. This is the complete circuit, outer circuit, and this is the salt bridge. And here are the electrolytes, and these are the electrodes, right? So this is the complete cell, half cell, and they completely form the cell. So E cell is equal to E right minus E left. So E right minus E left is generally used in case of numericals because there is a convention where we are using right and left. But here in this case, E of E reduction potential of the cathode minus E reduction potential of the anode. Since the potential difference in these two electrodes, the potential difference is the driving force for the electrons. It is also called the electromotive force of the cell or the cell potential, right? And it is measured in terms of volts, and a volt is a unit of electromotive force. It is the difference in electrical potential required to send a current of 1 ampere through a resistance of 1 ohm. So this is the definition of what is called volt, but here the unit of the electromotive force is measured in volts, right? So now the representation of a cell. While we are solving the reactions, how to represent this cell? So here on representing this cell, here we are having this zinc rod, so zinc, and this zinc rod, this represents the electrode, that this zinc and this electrode is in contact with its zinc sulfate solution, so zinc 2 plus ion solution. Now coming to the salt bridge. So salt bridge is represented by these two parallel lines. So here these two are parallelly shown over here, so these two parallel lines. Now coming to the cathode. So cathode here is copper 2 plus ions. Here these are the ions which are present in the solution, and these ions deposited over the electrode. So electrode is represented by this vertical line, and these are converted to copper. So from this equation you can understand zinc converted to zinc 2 plus while it is in contact with its electrodes, right? And this is the convention to represent the cell. While we are solving the numericals, we simply write down a cell in this manner, right? Now there is a trick how to represent a cell. So cell is on the left hand side, L stands for left, O stands for oxidation, and which this oxidation reaction occurs on the anode, and this anode is the negative terminal. So this is how you can understand the left hand side, and once you understand the left hand side, on the right hand side reduction occurs, which occurs on the cathode, and that is a positive terminal. Similarity and differences of the electrolytic and galvanic cell, and both are having two electrodes, and on the anode oxidation occurs, on the cathode reduction occurs in both the cases, right? Here we are having the reaction in the same compartment, but here in this case we are having two different compartments for both the electrodes, and electrodes are in contact with their solution of electrolytes which contain the ions common to the metal rod, right? Similarly here, and in this case we need salt bridge, but here no salt bridge is required. And the most important distinction is this: here the electrodes are connected with the external battery source or electricity source, and the positive terminal is connected to the anode and negative terminal is connected to the cathode. So here in electrolytic cell, anode is positive, cathode is negative, but here in this case this is connected through the emitter, and this is the negative terminal and this is the positive terminal, right? So I hope you understand this concept of electrolytic cells and their mechanism, their similarity, differences, and you also aware about the electrode potential, EMF of the cell. These which are very very important, and some basic terminology which is used over here. So if you understand this concept, please give me thumbs up and like, share and subscribe. Thank you all. Thanks for watching.